Okay, hi everyone. Welcome to another Wolfram language design review, part of our incremental language development series. And we have a variety of candidate functions to talk about today. Are these coming from the function repository?
Some are coming from function repository. Some of these are older ILD suggestions. This is kind of the switch over from some of the old design notebooks that we've been going through for a while to WFR, and there's some of these that are kind of interrelated. So,
what fraction are we through the old design notebooks? Have we pretty much mined those out?
We have pretty much mined them out. The remaining stuff is basically specialty things that we've forwarded on to specific groups. So a couple of suggestions for import, export, etc.
KeyValueScan.
So we have key value map.
I know
this was an older suggestion, but there's potentially some merit to being able to.
Do we care? I mean, to me, having this is not high cognitive load. Like, people will understand what it does.
It's the right. I mean, I'm not sure I see the value in this, right? Unless it, right? It's key value map semicolon. Unless,
well, unless it's very big.
Oh,
I
get right. I guess it's right. Yeah. Then it doesn't construct the return expression. So yeah.
And also, it has the possibility of having a return in the middle of it, for example.
Does scan respect?
Yeah.
That was the thing I couldn't remember.
Yeah.
Because I so rarely use scan.
I would say this is probably worth having. It's easy enough to implement. It's not difficult to understand what it is. Seems sensible to me. It doesn't seem like it's I can't immediately think of a fantastic use case, but I can think when we have more out of core kind of association like constructs, this is going to become more interesting.
Yeah, I was going to say the main use cases I've come across for something like this are, cases where I'm working with a large collection of data that's in an association, which is something that happens in the units framework, for example, and I want to batch process a bunch of things that has a side effect. That's often setting something. So it's not a huge problem to use key value map right now, or to basically.
Yeah, but why not have this? I mean, scan is better than map if you can use it.
Okay, yeah.
All right, KeySelect. Select's third argument is a count, right?
Select's third argument is a limit, yeah. So it's.
I think this is a no-brainer. I think we should have it.
Yeah. So I think the only potential controversy here is that select is somewhat different than a lot of the.
I know we have level specs, but there are no level specs in associations anyway.
Right. So I think it's pretty uncontroversial for the association case. But that leads into the next discussion point, which is having a select function that does have a level spec. We can't really modify select at this point.
Right.
If we added a fourth argument, then it'd be in the wrong position to every other function.
Yep. Why is
which, by the way, is exactly what tree select did.
What did tree select do?
We have a fourth argument that's a level spec.
That is a level spec.
Why not just make it an optional third argument?
Right, because the third argument is a count.
Yes, but it could be right. I mean, the three argument form is, if there are three arguments, the third argument is a count, and if there are four arguments, the third argument is a level spec. Just like,
I see.
One argument log, the first argument is the thing to take the log of.
We haven't done this very often, but
right, it's pretty rare, but it's not without precedent.
But let's
I'm
just
not sure we've
understand
ever
what-
done this in the case of level specs. That I think this would
Right.
be new in the case of level specs.
But let's just understand what the utility of this is anyway. So this is saying, I'm actually totally confused. I mean, in other words, this is saying,
Well, I suppose if you want to select,
it's just a map. I mean, I don't understand why this
It's
isn't just,
like it's like cases. Cases you can provide a level spec to.
I know, to pick things out, but I think it makes more sense in the case of cases than it does here.
why? I mean,
find
I don't
myself-
necessarily disagree, but
I frequently find myself using cases with a pattern that's just a pattern test when what I'm really doing is selecting.
I mean, I guess the more interesting question is what is the structure of the return?
Right.
I mean, is it
Cases is going to be flat. Is select going to mimic the structure of the input?
Yeah, exactly. Cases makes more sense because it is just reaping, so to speak. You know, it's just making a final list of results.
and select could do this? I mean, this select at level is apparently not doing that, but which I actually feel is a bit strange. Actually, I think I would.
Right. If you're going to have level specs that aren't an integer wrapped in a list, you almost have to make it flat. I can't even wrap my brain around how it would work if you were mapping it like at level 2 and 4 and then trying to maintain structure.
Yes.
For what it's worth,
Well,
tree select gives a flat list
okay.
for this exact reason.
I hadn't even thought of the flat list case. I mean, as we discussed, I mean, and by the way, I don't have a horror of the argument order being, I mean, he says, of the argument order being different if it's giving a flat list. Because it feels a little different. I mean, it's different from what happens in cases where you really are going.
I mean, cases gives you a flat list also.
I know. Okay, so it's a specious argument. But I mean, so the default is an infinity, comma. Well, no, it's not the default. I mean, that you could, in order to get.
It's level 1 by default.
Yeah, right. But in order to get all the elements on level whatever, it will be infinity, comma that level, comma the level specification. Okay, again, let's walk through this. So, Rick, in your examples, do you want the reaped flat list, or do you want some kind of thing where it's in situ?
Usually just the flat list, because for most expressions, what you would get probably wouldn't make sense if you just tried to preserve the structure.
Yeah. Actually, I kind of agree that this is useful. So now the question is, let's look at tree select for a second. I mean, what happened in our discussion of tree select that caused us to have the arguments in the opposite order from select?
And I will point out that
No,
tree
no,
select
no.
is
We followed the argument order of select.
No, we didn't. It's of select because it's n, but then select didn't have a level spec.
Right.
right.
But then our choice for level spec is inconsistent from every other function that takes a level spec that has it in the third argument.
I see. So a level spec for select. I don't quite understand. If you want everything.
Right. If you want everything at a not default
Comma.
level, you'd either need to say infinity or automatic or something like that.
Infinity
would-
or all, one of those.
Right, but it's got to be all comma 2. That would be one possible syntax, or 2 comma all. Now, in the case of cases, are you telling me that's how it works? I can say level, comma n. I see. I have to say, the fact that I have to say one, comma 1, comma n has always been a bit frustrating to me in cases. Yeah, I mean, in select, it has to be in that order.
So an optional third argument.
I think so. Heck. What do you guys think? I'm a little worried about this. What other functions are there in the family, like count, things like that?
Position.
Right. Well, I think those all follow cases, right?
Right.
Those are all pattern matching based
Mhm.
functions. So if I look at right, position, right. So position follows cases. It's expert, pattern, level, spec, max number. Well, count probably doesn't take a max number because it's counting, right? So
Yes. Well, it might still.
Okay, well, it's not documented too. Well,
Okay, fine.
So yeah, I mean, I suppose the I mean, one possible out, I don't know that it's any less ugly, is to have the level spec as some sort of option.
Yeah, I don't really believe in that.
Kind of like the optional third argument. Maybe it's because I'm used to tree having an optional first argument, which is also weird.
It's even more bizarre than this because brace to brace, which presumably works in cases for the level spec, would clue you into the fact that it's not. Well, I don't know. Does select take? Is it a take spec? The thing that's in select?
No, it's a count. Right, it gives you the first n elements. So it has to be a positive integer. I mean, I suppose one issue. Yeah, no, never mind. That was a stupid statement. But I'm pretty sure that it has to be right. You can't do -1, say, right? Yeah, it wants to be a non-negative integer. Non-negative, not a positive integer. So what does 0 do? Oh, you can put in 0 if you want to get the empty list.
The best way to get an empty list.
Yeah. Well, I will say that is the most efficient select possible.
Yes.
It runs in constant time.
Right. Let's see.
I also tend to favor the optional third argument. I don't love inserting a new argument in a new position, but as Itai said, there is precedent for it. It's not done super frequently, but it does make select symmetrical with the other functions.
Oh yeah,
consistent with them.
Right, and well, I mean, and then the question is, should we change tree select, which is experimental, to match select?
Well, Ian, what's
absolutely, yeah.
Okay.
We only had it fourth to avoid having to step into this problem.
So we changed this case.
Mm-hmm.
Fine. All right, let's do it.
All right. So these are two similar resource functions. that deal with selecting either indices or positions, or the result is either an index or it's a position spec.
How do we deal with this in nearest? Don't we have a mechanism for specifying the
Yeah.
return structure?
Yeah, there's
Yes.
the properties annotation, right?
This thing
Take,
here.
take largest, likewise.
Yeah,
So why aren't we
nearest
doing the
is
same thing with select? If we have an arrow property, well, the problem is because select is much more structural.
Yeah, select can take a rule as a first argument.
Yeah, it would be kind of a silly use of select, but it is,
Right,
I
yeah,
guess,
it's-
a valid use of select.
Yeah. Okay, so this is something that finds positions at which a particular criterion is true.
Right. So we're not returning the values, we're returning either the index or the position where the criteria is true.
Yeah, it's the select analog to finish the, well, analogy cases as to position as select as to what?
Yeah. And it doesn't relate to things like pick and so on, does it?
I would hope not. Pick being the miserable function that it is.
Tell us how you really
Really?
feel.
Yeah, yeah.
It's the implementation.
And nobody quite agrees on what it actually means. I mean, in sort of trivial cases where, list and val have are identically shaped, then we all agree. But the moment there's any room for interpretation, we don't all agree on what it means, and we're not.
The implementation is then the guide, and the implementation is misery.
I see.
It not only do people not agree, but what it's implemented to do disagrees with everyone.
Oh gosh. All right. Well, okay, so this question here. Didn't we just add index cases to various other functions?
I don't believe we added the index and value
And
notation.
how is this related to
supplied?
Supplied, yeah.
Yeah, I mean, my initial thought with this was that it was somewhat closely related to position largest, position smallest, which we did a couple of versions back. This is a slightly more general function in terms of taking an arbitrary criteria.
Would it make sense to have the rule syntax like nearest, but wrap it around the function being passed to select rather than the first argument? Because you could conceivably be trying to select either
Sure,
left or right inside of a rule, but a rule would never be a thing you want in the selector.
Right. So you'd need to remember your parentheses, but
Yeah.
And I think you could potentially use supplied to give different arguments to the test, but I don't think supplied should affect the output.
Or no, in this rule syntax that we're talking about, the string goes on the right hand side, not the left hand side, right?
Yes, but
right.
the point that you're making.
Right. Well, I'm just saying that means we don't have to worry about parentheses because the ampersand will be on the left side of the rule.
Fair point. But there's also select indexed and so on, which is what supplied should deal with.
Correct.
Sense?
Yeah.
Right. Yeah. Indexed in the sense of it takes the index into the test.
Yep.
Mm-hmm.
What other missing functions are we going to immediately think about if we add this?
Trying to remember what we've already added it to. I remember we've added it to a few things recently, but I honestly don't remember what. Does anybody else remember?
And some stuff with find shortest tour, I think.
Oh, yes.
Well, we have the triple position cases count. If select is to position and this, sorry, if select is to cases and this is to position, then it would be the equivalent to count.
I don't follow that.
So the triple count, position, select, they always go together. Again, count, position, cases. Now, select is the equivalent of cases. And I think this function we are discussing here is the equivalent of position.
Yes.
So the question is, do we need the equivalent of count?
Select count.
Yeah, how many things satisfy this criteria?
Does count by have any hope of achieving that? Or is that too convoluted?
What does count by do?
Do we have count by?
Do we have a count by? Yeah, there's always the possibility that I'm
We have-
completely making this
Yeah,
up.
I think you're
We
making
have
it up.
counts by. but
Yeah,
not
counts by.
count.
Counts
Counts
by.
by is a different thing.
Okay.
I agree
What-
that there's also a count here.
Mhm.
That
I just put another one from the function repository in the chat where I find this useful sometimes. I used to find myself writing, get the positions and then take the positions from expressions all the time. And this just kind of combines it into one.
yes, this is useful. I mean, there's also just turning an expression into its
Right. Sparsify or whatever you want to call it.
right into its parts. This is almost like part association.
Yes, but with a test, with a pattern test.
Yes. Although it could have a select too.
It could. There could be position select. Especially now that select has level spec.
Boy. Well, I prefer, I mean, part association. Seems better for that. I don't know. Let's try and get a more systematic report on all of these kind of orthogonal cases. Okay.
Okay. Take a proper inventory of the select related functions.
Yeah,
and the
select
related
cases
functions.
count across and their return values and what they eat and associations and things like that.
Right. So, okay. So I'm not sure exactly what this function does, right? But the basic issue I think we're dealing with is that, by the central dogma, cases cannot see the keys.
Yep.
And so if you want to do some sort of cases that can test the keys and possibly
I don't understand why supply doesn't solve this.
No, I think this is the rule thing. What did we call it? Like position pattern that simultaneously matches the expression and its position, which in this case would include the key.
Right. Okay. Yeah. That's yes. If we had somebody to implement position pattern, that would be that would be a solution.
Well, position pattern sounds like a special case of supplied.
Well, no.
So supplied. Go ahead, Itai.
Right. Supplied lives in the functiony world, in the map world, whereas position pattern lives in the cases and pattern matching world.
Yeah, position pattern sounds like a really good thing to have. However, key cases is a concept that's easy to understand.
Right. So
So maybe key cases is worth having. I mean, the fact is, occasionally machine generated things have complicated left-hand sides in their associations. Human generated ones tend not to. They tend to be things like strings.
okay. So I'm not sure. Oh, I see. One is using this key cases and the other is using KeySelect.
Yeah, this was just showing, in principle, you can make key cases out of KeySelect with match queue, but there's some cases supports, for example, the transformation rules in the pattern, which select doesn't really. Say
Right.
I want to replace all of the instances. I want the association that has all the f of x's and replace the f of x with x.
Oh, so this is only pattern matching against the keys.
Right.
So this, in fact, is significantly less powerful than
Position pattern.
position pattern.
Mm-hmm.
Yeah, it's
And
a direct analog of KeySelect.
and right. And well, I guess, well, I mean, if we supported some sort of, maybe this isn't a problem, right? But the moment you support transformations, then you risk collisions in the keys, and is that what you want, right? I mean, it's certainly potentially confusing whether or not it's the right thing to
Probably have
do.
a merging function option. By default, it would just be take the most recent item like association normally does.
Sorry, in key cases,
Right, we're pattern matching against the keys. So if we
Yeah.
allowed that thing to not just be a pattern, but a rule, then in the output, in the result, we
you
risk
could have
key
you could have
collisions.
colliding keys. Yes.
So we would need a merging function for the collision cases.
I think key cases is worth having. I think it's easy to understand. I think like the other thing we just had, it's kind of cognitively easy. You've got KeySelect, why not key cases?
Mm-hmm.
Now, I agree there needs to be a merging function. If we allow this form.
Yeah.
That form is fairly exotic, but I don't see why we shouldn't allow it.
And then if the keys were actually rules, you would wrap it in key.
Or hold pattern.
Hold pattern, yeah.
Hold pattern.
Right.
That's what my thought. Yeah.
Just like if you want to match rules with cases.
Right.
Yes. All right. Counts merge.
So this is a suggestion from a while ago by one of our live stream viewers. It is a variant of counts that allows you to specify the expected values and give a default value.
Huh?
In other words,
I don't understand. I don't understand that sentence.
Where the satisfaction is
I
1
would
through
use
5,
this.
and if somebody puts a 7, it isn't
Yes.
counted.
The
And
default value
almost-
would typically be 0.
And almost more as important is the order of the output matches the order of the second argument.
Right.
I find I always, after I get counts, I have to reorder it a lot.
Yeah, I would use this
Yes.
a lot. I've few cases where I would definitely use this.
I don't 100% love the name that was suggested.
No.
But
Yeah.
I mean, somehow this feels like it's part of the categorical data family. I mean, I have to say, I'm not keen on this. I don't understand why the functionality isn't first you do the breaking, putting things into, I mean, the function that takes a list and has a set of values that are allowed and takes everything else to be missing. That seems like a useful function. This is then wrapped around that. See what I'm saying? There should be a function that normalizes a list by saying, here are the allowed values, here's the out of range values, make the out of range values be whatever you specify. For
so
example,
it trims outliers or, you know.
yeah, and I mean, I think you might even want, if it's numerical values, you might want a whole set of rules for what the missing stuff does. I mean, this is basically, yeah, this is a useful function. If it's in a certain set, just pass it through. Otherwise, missify it. Do you
I
understand
think
what I'm saying?
what might actually be the more general form of this is maybe give a default value to key take as an extra argument. Because then you could just run counts and do key take with your range of 5 or whatever, and then give an extra last argument saying what you want the default to be.
Yeah, except that this isn't keyed yet. I mean, you could do
Well,
counts,
do key take of counts.
Yes, you can.
But then there's a lot of other association types that aren't necessarily counts that you'd want to do this exact same thing with.
Right, but I'm saying I think the more general thing to do is we just have a function that prunes, could even be called prune, possibly, that prunes something down to a certain set. Okay, and if it's outside that set, it either has a fixed value or it applies a function to determine what to do with the things that are outside the fixed set. So for example, I would say, you know, like prune, or more like conform. Now, more like prune, actually. Prune this list to my set, and that would give a failure object or something by default. And then here we have a function that's applied to everything that isn't in the prune set. I kind of like this function.
Is this not just, I mean, I suppose a 3 argument form maybe requires a bit of thought, but isn't the 2 argument form just delete cases, you know, maybe with an alternatives at?
Yes, it is. So the case of the complement of that.
Oh, yes, you're right.
But the idea would
I mean,
be
it's
that
closer to
it
keep
wouldn't
case.
strictly remove
Right.
them, right? It would replace them with.
Yeah, you're right. And it isn't quite prune. It's some kind of normalized type thing.
Yeah.
I like this
Common.
function. It needs a better
But-
name. What's that?
Yeah, a common case would be almost an inverse of delete missings would be insert missings, or, you know,
Yeah, exactly.
identify outliers. I mean, that's maybe a bad method, but
Okay, so I'm sorry, but I mean, this seems like a fine function, but I'm not sure why we want to be inserting missings, right? Because the missings, right? The missing here is not from the, right?
It's out of range.
No,
out
it's
of
not. This missing, in the examples that we see in front of us, the missing is not from being out of range. It's from the fact that there are no 5s in the input.
That's why I was saying I think 0 would be the more common case of using this, because if you are dealing with counts, do you want something that's not in there to be assumed to be 0.
Yeah.
Oh, I see.
So
I
then
think
if
that-
you're like incrementing values in there or
I mean,
something.
you're not in there.
Right. So if you look at the input right
Yeah.
before the bullet point, then the 4, which is not in the list, is just counted as 1, which I was actually going to ask about if that's really what we want, that things that are not in the expected set just sort of insert themselves into the results without any warning.
Okay, so there are 2 issues. One is there is a value not in the expected set, and there are no values for a particular entry in the expected set.
Right.
Yep.
Sorry, is the expectation set keys or values?
There are no
It-
keys
it-
here. We're not talking about keys, it's just values.
Well, it's keys in the output of this particular function that's being in the particular function that's proposed
Yeah,
at
but
the
I mean,
beginning
but
of the
look-
section. But
What we're dealing with here is we want this function to operate on values. It's just a list. The first argument can be thought of just as a list, or maybe it's an association, but then
we central
Right, but
dogma it.
The values of the list become the keys of the association. And I guess that's what's kind of confusing me there. If we're expecting to see range 5, but we count something 10 times, is that going to leave it as is or chop it?
No, the right, the 10 would be a value.
In the output?
Yeah, so
Yes.
there's 2 different things we're talking about. The first, the counts merge function that's proposed there started a discussion about a more general function, which would be this prune function. And the prune function, or whatever we decide to call it, is I have a list or a set of data, and then I have my expected values. This counts merge is kind of a combination of that function and a counting function.
So how is there any relation here to key drop?
No.
No.
I think there's a relation to key take though.
Hmm.
Yeah, well, or is okay. Key take just keeps a certain amount of keys.
And it will
It
order.
takes a certain list of keys.
Yeah.
But what it doesn't do is fill in something with default values if it's not in the original set.
Well, that probably could, but it is doing it based on keys. This is doing it. I mean, this is
Right.
the value equivalent of key take.
There's also an analog to lookup, which does just returns values, not an association, but it fills in missing things.
Yes,
Right. You could do it with lookup and thread, I guess.
if you have an association. But I mean, this is operating on a list. So, for example, prune. Look,
And lookup drops the values that weren't in the expected list. So it wouldn't match what we have in the notebook for counts merge.
Right. I mean, maybe we should call this function keep rather than prune.
okay, so there are 2 possibilities for what that could give. One is AB, AB, which is essentially a select. And the other is AB failure three failures in a row.
I'm not sure it should be a failure. That just sounds very aggressive.
Or maybe it's missing.
Yeah.
Or whatever. I mean, the default
Right.
value, whatever the default value is, which we don't know.
Well, we could just say the default value is nothing. And you get that first behavior, and then
Right.
if you specify a default, you get the second.
Yeah.
It's interesting. Yeah. As long as we're
Only working
doing
on
it for
lists.
lists. Yeah.
True, yeah.
Well, I mean, it's not the worst thing in the world to see a nothing and something else. And it's, you know what happened.
And then the second part is that question of what we do if your expected set is A, B, Z, and we don't have Z's there.
Yeah,
Does-
what do we
Does
do?
the
in that
first
case?
start, does the first argument have to be a list, a simple flat list?
Well, maybe not, but what do we do in this case? Yeah.
Right.
I don't
Well,
think we can do anything other than, because it's not keys, we're not leaving a space for the Z's.
right.
Yeah, I think if we're keeping it structurally the same as the input, there's nowhere to insert a this didn't occur.
Right. This is purely a thing for normalizing, conforming, pruning.
Yeah, so that I guess
I
yeah,
mean,
the
is
analogy
it-
with lookup is that lookup will give an exception if something is missing. This will give an exception if something is extra.
Here.
Yeah, if something is unexpected. So
That's
Yeah.
basically specifying what's allowed in the list, not necessarily that it has to have all those items.
Yeah,
Right.
right.
Yeah. I mean, I think if for this prune function, right, there can't be any special behavior. Now, the question is if we had this, counts merge or whatever function, what would it do in that case? Or no, this case is fine. Yeah. It'll just
Isn't-
say 0.
Isn't this
Yeah.
prune just replace except goes to nothing?
Yeah, and
Yeah.
doing the
Yeah,
apply
or
alternatives.
it's or delete cases except at the list.
Right.
Yeah, but you can also do cases alternative and then just flatten or concatenate the results.
we'd have to have alternatives around the except or
Yeah,
instead of a
yeah.
list. but-
No, I mean, it's a bit complicated. I mean, every function can be expressed in terms of other functions. So the fact that it
Right.
can be expressed doesn't particularly.
Right. And
Yeah,
well,
but I mean, how many other functions? Because I think in this case, we're only talking about combining 2 or 3 things.
I know, but the question is conceptually. The name prune isn't great, but I think there is the possibility of a really good name for this. Like conform, but it isn't that either.
well, it could be keep, prune to.
If it's going to be prune, then does it make sense to leave a bunch of junk in the middle of a
No.
list?
That's why, well, if its default
Mhm.
is nothing there, then its default is to prune.
Yeah, but the general function isn't really a prune.
Yeah,
It's
but
more,
in the
it's
case
kind
of
of like a
nothing,
filter is what or a filter or a projection almost.
yeah, but this case, right, is the case with nothing is purely
Alternatives applied to, yeah.
all right. We've introduced this. We need to marinate it. I actually need to go fairly soon here.
This is one of Rick's functions that he mentioned, and I think it has a lot of merit. It's basically a modernization of REAP, where instead of getting a structured result with positional tags that you have lost, it has a decorated association that has the results and then the various tags as keys.
Why doesn't it have like the position where it's being set? No, it can't know that.
Yeah.
This requires more thought. I mean, I think that this is
The benefit of this doesn't matter what the first item was that was shown, because you can just get things by key. Otherwise, with REAP normally, you would get the lists in the order that the tags are first seen. So you'd have to know the underlying code, what it was doing.
That none is the fact that the so didn't have a second argument. Is that correct?
Yeah,
Right.
it was
It's more
the
interesting with
arbitrary
tags.
thing I chose.
Well, the idea of a reap so where it can give an association there is an interesting idea, but are you sure there's no way to fit that into the argument structure of so and reap?
No, I mean, right, you could throw none, in which case, how do you distinguish that, right? I mean, one argument for so is not the same thing as.
Yeah, well, it's an argument against this. Okay, this is an interesting idea, needs more thought, and I'm trying to escape here, unfortunately. Oh God.
You know, if you need to
Yeah.
escape, I don't think there's any problem with just saving these for the next agenda.
Fine, let's do it.
Okay.
right.
One comment briefly is I really like this last one, reap association or whatever it was called. I mean we really it is something that has been lacking.
Let me understand what the point is there. The point is that you want to have tags.
Yes.
You want to use tags and sort according to the tags.
Or at least know what goes with what tag, what group goes with what tag. That's what's been missing. Anyway, I didn't mean to keep you long. I just wanted to
No.
interject
I agree
that.
that that's a thing, but I mean, I'm kind of wondering whether there's a way.
I think I might have beat you to it, Rick.
Oh, whoops.
Chat wars.
Yeah. Yeah, I mean, you can come pretty close with the 3-argument form, but
Okay, fair.
right, it doesn't have that outer association, which might kind of be good because the names result in zone are kind of arbitrary.
Oh yeah, what I was showing and the thing I chatted was the default behavior. You have to know what tag is being sown first to make sense of the output.
Right. That's what I think is not so great.
What do you
Yeah.
mean? You have to, because how do you, what isn't the result always the first argument?
If you try evaluate what I put in the chat.
The result of the evaluation is the first argument of reap.
Right. But to use the second argument, if you don't have a third argument in your reap, you're just guessing
So that
what
A and B,
sowed A and what
that
sowed
came
C.
first because that tag was sown first. So you would have had to know what the code was going to do, the underlying code, to make
Yeah,
sense.
it's implementation dependent.
I don't even understand what it did. Why are the A's and because they're tag 1. Oh, I see. You have no idea which tag is which.
Right.
Yeah. So if you replace
Yeah.
tag 1 with tag 2 and vice versa,
Sure.
you get them in a different order.
I have to admit this reap association makes decent sense to me, although I wouldn't bother to have that outer sown result, et cetera, et cetera. I think that's a mess.
I
just have-
agree. I don't know why I thought it was a good idea back when I made this, but it probably should just be a list with the result and an association of the.
Right.
the
So
sum.
really, this is different from reap only in the sense that it is getting things in an association, which makes perfect sense to me.
So it's basically the same as in 47, but the second argument is wrapped in association.
Yeah, and that's
But it's still its own function because that blank comma rule is weird. Right.
Yeah.
that's probably what I did in the implementation.
Okay.
Something like that.
Okay, but what do we do with the none?
I mean, anything we put there can potentially be a tag, is the problem.
Yeah, I know.
Oh, so reap
Some things are
catches
more-
both one argument. So reap blank catches both one argument and
And
two argument sows, which is different from throw and
Mhm,
catch.
mhm.
Um,
This is a good function, I agree. So I think we just have to solve the problem of what the, I mean, but by the way, how many arguments does this crazy thing have? Reap has a lot. I mean, it's a pity that there aren't like named elements here of the reap output, which is what I think you were going for. But I think at this scale, you know, the more common thing is going to be, I just want the stone tag, so to speak. I'm not sure. We need a better version of none. What the heck do we do? What does pattern matching do when an argument is simply not there? What does it do? It's a null
Something
sequence.
sequency?
Yeah, it's, I mean, it basically, it's a crazy null sequence.
Right. Well, it's not literally, right? It's just removed from the
Yeah.
Which
right-hand side.
technically that single underscore shouldn't match it, right?
Well, maybe there could be just be two separate associations, and that would avoid key collision.
Well, it isn't an association, it's just one case.
Yeah,
I
that
mean, maybe what it is it's a list of three things. The result. Go ahead.
The unnamed,
The unnamed
someone,
ones, and
so
then
on, and the
tag
rest.
ones.
Yeah.
yeah, the
seems
unnamed
plausible.
ones make sense as a list because there would be no key.
That's possible. Let's ponder it. See whether we can make that work. Yeah, I mean, that's unambiguous at least. All right, I have to go. See you guys soon.
Bye.
All right. Sounds
Bye.
good. Thanks, everyone.
Bye.
Bye.